the slow. That's Comet ISON from the slow's space camera. It's supposed to be a live shot. Let's see if it moves. Slow's space camera. It's been running for 8 minutes. It's live. And there it is. So there's 2 little dots by it and one above it. Oh, now the both of those are spoken. There's this thing, and there's this thing. It's green. And it's purple. On. Purple and green. We can remind ourselves what Comet ISON felt like before it disappeared for a couple of months. So heartbeat telescope Comet ISON on the 28th of September 2012, and that was only 7 days after it had been discovered. Now you can see that even where but while Dave was using the half-meter telescope, another SLU member, Nermal Paul, I think Nermal's from Calcutta, so this show is the first show I think we've ever done, which is well timed for Nermal. Hello Nermal, I hope you're watching. Anyway, he used the other telescope that we're using for the real-time images tonight, the SLU T2 high magnification telescope. And the high magnification telescope, you know, it doesn't gather the same amount of light as the half-meter. But you can just about make out the tiny smudge, which is Comet ISON. Now, SLU members continue to track the image, track and image Comet ISON virtually every single night since then, and we've watched it gradually brighten over the weeks and months. Now, I've got a little time-lapse video that I want to show you, and I put this together from a series of our images, and it shows Comet ISON as it moved across the background stars at the beginning of February, I think this was. Now you can see it's still pretty faint, and it was way away at that time. Now we're going to cover this in more detail on a show that I'm going to be broadcasting on comets and asteroids every Sunday night this month, so make sure you keep an eye open for those. We're going to go into this a little bit more, but this is actually how astronomers usually discover these tiny, faint objects, because you can see they're really difficult to pick out in a single image. So what astronomers do is they take 2 or more images of the same star field at intervals, depending upon what they're looking for, ranging from a couple of minutes, this looks pretty weird behind
Earth, up to a few hours for more distant objects. And you know, Clyde Tombaugh, you may have heard of him before, he used that same technique to discover the now demoted dwarf planet Pluto back in way back then. He was actually taking images on glass plates with exposures of several hours. He then viewed them in this fantastic device called a comparator, And if you've ever been to the Lowell Observatory, and if you haven't been, you need to go there. They've got the comparator set up there. And that's where I took these images that you're seeing now, poking my digital camera down the eyepiece of the comparator to show Tombau's actual Pluto discovery images. And you can see that's what he's doing. It would be impossible to spot Pluto just in a single image. But found is how most near-Earth objects, asteroids and comets are found by taking two images of the same portion of sky and comparing them. Anyway, I digress a little bit. Let's get back to Comet ISON. Now, what are these real-time images looking like at the moment? This is from the T2, no, this is the T1, this is the half-meter telescope. Now, you might see that the image has got a lot of gradient coming in from one side, and that is because we have got 20 minutes before astronomical darkness ends.